All right, for number 61, notice you have something times something equals 0, and we're supposed to solve, so that means we can use the zero factor property. One of these sets of parentheses must be equal to 0, perhaps each of them is. Okay, so you simply take the first set of parentheses. This isn't an algebraic step, this is based on the zero factor property. Okay, you just grab 3y plus 11 and set it equal to 0, and then you grab the other set of parentheses, 2y plus 23, and set that equal to 0. And now you solve each of these for y. Okay, so get rid of the 11, get rid of the 11. 3y equals negative 11. Get rid of the 3, get rid of the 3. Y equals negative 11 thirds. That's one possibility. And then you look over here. You want y by itself. Get rid of 23, get rid of 23. You're left with 2y equals negative 23. Get rid of your 2, get rid of your 2. You're left with y equals negative 23 halves. Okay, so your answer is going to be y equals negative 11 thirds, comma. I was hoping to keep it on the paper, but I guess that's not going to work. There we go. So negative 11 thirds, negative 23 halves. I did forget my negative there. Okay. These are the solutions to this equation. And it might be some work to plug them in, but if you put in a negative 11 thirds, here you'll get a 0, and then 0 times anything is 0. If you plug in negative 23 halves, here you'll get a 0, and 0 times anything is 0. Okay, so you can check your answers. Might not be real easy, but you can. Okay, number 62. You have something times something equals 0, so you can use the zero factor property. Okay, so you grab the first term, you say x equals 0. You grab the second term, basically, but I'll say it's not really a term; it's two terms. But they're grouped together in parentheses. So you grab that set of parentheses, 3x plus 6, and you set that equal to 0. Okay. And this one's already solved, but this one you've got to do a little work. So get rid of your 6. 3x equals negative 6. Get rid of your 3. And x equals negative 2. Okay, whoops. So your answer is x equals, I usually put the smallest values first, negative 2 comma 0. All right. And again, if you plugged in a negative 2 there and there, you would get 0 times, well, this would turn into a 0, and 0 times anything is 0. If you plug in a 0 there and there, this is a 0, and 0 times anything. All right. So I'm just emphasizing you can check these. Number 63 might look a little bit bad because there's fractions. But it's already in factored form, and that makes your life a lot easier. Okay. So number 63, if you have something times something equals 0, you just grab each set of parentheses and set it equal to 0. Okay. You're using the zero factor property. So 2x plus 7/5 equals 0, or 4x minus 5/7 equals 0. Sorry, a little bit off my page here. And get rid of your 7/5 minus 7/5 minus 7/5. I'm definitely going to run out of room on this. So I'm left with 2x equals negative 7/5. I want to get rid of the 2. Might look a little confusing if I simply divide by 2. I can divide this side by 2, but it'll look confusing over here. So I'll make this 2 over 1. I can always do that. So now the fraction 2 over 1 is held to the x by multiplication. To get rid of it, I'm going to multiply. When you multiply, it's held there by multiplication, so I'm going to get rid of it with division. When you divide by a fraction, you flip it and multiply. So I'm going to multiply by 1/2, and that means I have to come over here and multiply by 1/2. And I think you can see on the left the 2's cancel, and you're just left with x equals, and here nothing will cancel, so I get negative 7, 5 times 2, 10. Alright, so that was my first one. And then over here I'm going to get rid of the 5/7 with plus 5/7 plus 5/7. That'll leave me with 4x equals 5/7, and let me kind of keep that split up. Again, I'm going to be dividing by 4. If I just read this, it's held by multiplication, so I'll use division. But it might look confusing to you to divide that by a 4. So if you want to see a fraction here, you just turn that into a fraction. And now the fraction 4 over 1 is held there by multiplication. To get rid of it, you'll use the opposite operation, which is division. When you divide by a fraction, you flip it and multiply. So that's 1/4. 1/4. And the 4's, notice the left side, that always cleans up real fast. 4 goes into 4 once. So you have x equals, and over here nothing cancels, 5 over 28. Okay, so your answer to number 62 would be x equals negative 7/10, comma 5/28. All right, so that's your answer. That takes care of 63. We'll jump down to 66 now. And this one is not in factored form yet. Okay, so let's see if we can zoom in some. That might be getting hard to see. Hopefully that helps. Notice earlier, let's go back up here. Like you had something times something is 0, and even on this one it was still 2 sets of parentheses, which means to multiply. So you had something times something is 0. Same thing going on in 64 and 65. But when you get to number 66, you just have things being added and subtracted, and you have x to the second power. Notice in all of these other ones, x or b or whatever it was always to the first power. Okay, and we know how to solve those. I'm going to slide this all the way up now. But when you have x to the second power, we don't really have tools for solving that. Okay, so what we're going to do, at least directly. So our indirect method is we're going to see if we can factor this trinomial. Because if we can have something times something equals 0, we'll be able to use the zero factor property and solve for x. Okay, so going down our list, GCF, nope. 2 terms, nope. 3 terms, yes, and nothing in front of the first term. So you just grab your 55 and list all the factors. Maybe I'll do that way over here. So 55, list all the factors. 155, 5 and 11. We're looking for a difference of positive 6. So if we had positive 11, negative 5, we would get there. So this trinomial can be factored as x minus 5, x plus 11. And now we have something times something equals 0. So you just take x minus 5 and set it equal to 0. Sorry, I'm off the page here. And you take x plus 11 and set it equal to 0. And now solve for x. So that would be plus 5 and plus 5. And minus 11 minus 11. So the answer is x equals, whoops, I didn't need that comma there. Negative 11, I usually put the negative first, put the smallest numbers first, and positive 5. Okay, so these are the two solutions. And this one might be a little easier to solve or to check. You can always check answers if you're solving an algebraic equation. If you plug them in here, you'll see that at least one of these turns into a 0, and something times 0 always gives you 0. In fact, if you plug it in way up here, if you plug a 5 in here and here, you'll get a 0. If you plug negative 11 in here and here, you'll get a 0. Okay, so you can check these. 66. Let's take a look at 67. First thing you always do is look for the GCF. 67. And there is a GCF of 3. So we'll factor out a 3 from each term. And whatever we end up with is still equal to 0. Alright, factor a 3 out of there and you'll have x squared. Out of there and you'll have negative 9x, and out of there you'll have plus 20. And you proceed down your list. 2 terms, no. 3 terms, yes. Nothing in front of x squared. You grab your 20. List all the factors. 1, 20, 2 and 10, 4 and 5. If that's positive, it's going to be a sum of negative 9. So negative 4, negative 5. So the factored form is x minus 4 and x minus 5. Bring down your 3, and this is still equal, to 0. Now we're solving for x. So we'll basically set each term equal to 0. The first one is kind of ridiculous. 3 is not equal to 0, so we basically toss that. Okay. Your next one, x minus 4 equals 0. You'll be solving for x. And then you take your x minus 5 and set it equal to 0. Okay. And then solve for x. So add 4. Darn it. Add 4. Add 4. And you get x equals 4. Add 5. Add 5. And you get x equals 5. So your answer, if you solve that equation, you get x equals 4 comma 5. Okay, 67. Now 69. Okay, and notice if we compare 69 to 68, I'm not going to solve 68, but I'll refer to it. This one equals 0, and we've been using the zero factor property. This one equals 42, so that's a problem. Your first step is really going to be get rid of that 42 because you want this thing equal to 0. So to get rid of that 42, I'm going to subtract 42. And how do you know? Well, if I was to divide by 42, I would end up with a 1 over here. I don't want a 1, I want a 0. So I subtract 42. If I do something on one side, I have to do the same thing on the other side. And to rewrite this now, you have x squared. Squared's not coming out very good. Alright, x squared minus x minus 42 equals, usually when you do this you don't have to write the 0, but I can't have air on this side of the equal sign, so now I have to write the 0. Alright, so let's slide this up and you proceed down your list. GCF, nope. 2 terms, nope. 3 terms, yep. Nothing in front of x squared. So you grab your last term, your 42, list all the factors, 1 and 42, 2 and 21, 3 will go in there, 3 times 16, 15, 3 times 14, 3 times 14, 4 won't work, 5 won't work, 6 times 7. We're looking for a difference of -1, so it must be -7, +6. The factored form of this trinomial is x plus 6, x minus 7. That still equals 0. I have something times something is 0. So I just grab each one and say, well, either x plus 6 equals 0 or x minus 7 equals 0, and then solve for x. So subtract 6 from each side, x equals -6. Add 7 to each side, x equals 7. So the answers are x equals -6, 7. Okay. We'll take a look at number 70. And again, we've been working with things equal to 0, and that's not, we don't have that. So I'm going to get rid of that 25 by saying minus 25 and minus 25. So I have 36x squared minus 25 equals, again, usually I don't have to write something over here, but I can't have air on that side, equals 0. And now you proceed down the list. Is there a GCF? No. Do you have 2 terms? Yes. Is it a difference of squares? It's a difference of perfect squares. So you can factor this. Okay? So that would be square root of 36x squared, 6x. Square root of 25 is 5. And you just have to remember that 1 is positive, 1 is negative. So you have something times something is 0. So you grab each set of parentheses and set it equal to 0. 6x minus 5 equals 0. Okay. I'll have to back out a little bit here. So get rid of your 5. 6x equals -5. Get rid of your 6. So x equals -5/6. That's one possibility. Guess I have to zoom out again. And for this one, add 5 to each side. And you have 6x equals 5. Get rid of your 6. X equals 5/6. Okay, so your answer is x equals -5/6 or +5/6. Okay, those are both solutions to this. number 70. And let's see, we will also take a look at number 71. And again, we've been working with things equal to 0, so that's where we want to be. I have to zoom in a little bit here. Hopefully, I'll go one more. Alright, so I want it equal to 0 instead of 63x. So I better get a different pen. You're going to subtract 63x from each side. So you'll end up with x squared minus 63x minus 64 equals, and 63x minus 63x is 0. Alright, and then you just proceed down the list. You have a GCF? Nope. 2 terms? Nope. You have 3 terms with nothing in front. Alright, so you just grab your 64 and list all the factors. 1 and 64, 2 and 32, and I could keep going, but I'm looking for a difference of negative 63, and I've already got it. Alright, so the factored form is x plus 1, x minus 64. And if you have something times something equals 0, grab each one and set it equal to 0. X plus 1 equals 0. And x minus 64 is equal to 0. So I'll have to zoom out here. So to get x by itself, you would subtract 1 from each side. X equals negative 1. To get x by itself, add 64 to each side, and x equals 64. So your answer is x equals negative 1 comma 64. Okay, and let's see. 71, 72. We'll take a look at 72 here. Actually, 72, 73, and 74, I think I'll just put them on the next video. They're a little more involved. Okay.